For today's lesson, we will look at finding side lengths of triangles using trigonometry. We will do examples where the unknown is the numerator. The numerator is the top of a fraction. Before we begin, I want you to look at this equation. If we were to solve for x, what would we do? Well, we would use inverse operations like we did in linear. So we would multiply this 3 to the other side. So we would get 3 times cos 20 equals x. Now to figure this out, I can just put this in my calculator. 3 times cos, now remember I showed you how to get the sine, cos and tan buttons on the calculator, 20, and just type that in and you should get 2.82 equals x. These are the steps to follow. Label the given sides of the triangle. They're the ones with letters or numbers on them. Use so, ka, toa to see which trig ratio it is, so sine, cos or tan. Then lastly, you substitute the values from the triangle into the equation and then solve like I did on the previous slide. Here's an example. So my first step is to label the triangle. I've got the hypotenuse, and if I put my finger on the angle, I won't touch the opposite side. So that means this is the opposite. Next, I need to decide if I'm going to use so, ka, or toa. So my triangle has the O and the H, so I'm going to use sine. So I write out my trig ratio for sine, which is opposite over hypotenuse. Then the last step is I substitute and solve. So the value of the angle in this triangle here is 38, and the value of the opposite side is x, and the hypotenuse is 7. So I put them into the equation like that, and my last step is I need to solve this for x. So to solve, I need to multiply this 7 to the other side. So I'll have 7 times sine 38. That will give me x. So if I put that into my calculator, 7 times sine 38, I'll get 4.31 equals x. Example number 2. My first step is to label the triangle. So if I put my finger on the angle, I won't touch the opposite side. So that makes this the opposite side. The hypotenuse I don't label because it's got no information on it. And this last side here, I label A. So now I need to decide, am I going to use so, ka, or toa? So I've got O and A. So I'm going to use tan. So I write out tan, the trig ratio, which is O over A. And my last step is I substitute in and then solve. So with this triangle here, the value of the angle is 42. The opposite side is x. The adjacent side is 4. And now I can solve. So I need to multiply this 4 to the other side. So it's going to be 4 times tan 42 is going to give me x. I pop that into my calculator, which equals 3.60. Last example for today. So step 1, label the triangle. So this one they've tried to confuse us here because it's upside down. But I know that this is my hypotenuse, the longest side. If I put my finger on the angle, I won't touch the opposite side, but I don't label it because there's no information on it. And so I label my last side with A. Next, I need to decide if I'm going to use so, ka, or toa. So we've got for this triangle A and H, so it's cos. So I write out my cos ratio, A over H, and my last step is I substitute in the values from the triangle and then solve. So the angle for this triangle here is 24. The value of the side with A is x, and my hypotenuse is 10. Last step, I then solve, so I'm going to multiply this 10 to the other side. So I'll have 10 times cos 24 equals x. Pop that into the calculator and that should give you 9.14 equals x. Okay, so there's a worksheet where I've just lifted questions from the textbook for you to do. Answer in your workbook or on a piece of paper and take a photo on your phone, and then you can submit it. Or if you really want to, you can do it in the Word document, but I think it's going to get a little fiddly.